So, you've got data, but how do you make it stand out? In this video, we'll walk you through creating stunning charts with Jetpack Compose. Step by step, you'll learn how to bring your data to life and build amazing visualizations for your Android apps. Now, it's time for the grand finale of our Cashwise app series. In this final episode, we're tying everything together to create a fully functional budgeting app. Here's what's on the agenda. First, we'll implement a sleek bottom navigation bar, making it easy for users to switch between key sections effortlessly. Next, we'll focus on the transactions screen, where users can view and manage their finances. We'll also add smart filtering options to help them quickly find specific transactions. Then comes the analytics screen, the real game changer. We'll integrate the charts we built with Jetpack Compose to visualize spending habits in a clear and insightful way. Finally, we'll wrap things up by building a settings screen, giving users control over their app preferences. All right, let's jump into the code. First, we need to update our dependencies in the libs.versions.toml file. We're also defining a new version for Coil, a powerful image loading library for Android. Next, we need to integrate these libraries into our project by adding them to the design system module's build.gradle file. In today's world of diverse devices, designing for multiple screen sizes is a must. Whether it's a phone, tablet, foldable, or even a multi-window setup, your app should look great everywhere. Luckily, Jetpack Compose makes this easy. It uses window-size classes to categorize screen space into compact, medium, and expanded, allowing us to create responsive layouts effortlessly. Check out how our Cashwise app adapts to different devices. On compact phones, we stack income and expense graphs vertically for better readability. On foldable devices, we leverage the extra space to display them side by side, making the most of the wider screen. This code defines a window type sealed interface along with a remember window size composable function to dynamically determine the current window size based on screen width. It also creates a composition local window type to provide this window type information throughout the app. Here's how the classification works. Compact. If the screen width is less than 600 dp, it's categorized as compact. This typically includes smartphones in portrait mode. Medium, screens between 600 dp and 839 dp fall into this category. This might include larger phones in landscape mode or smaller tablets. Expanded, any screen 804 dp or wider is considered expanded, covering large tablets, foldables, or desktop-like experiences. Move to your theme class and update it. We're using Composition Local Provider to make window size information available throughout the entire app. Now let's talk about bar charts. A bar chart is a powerful tool for visualizing data, using rectangular bars to represent different categories or values. The length or height of each bar corresponds to its value, allowing users to quickly compare data at a glance. All right, let's break down the math behind our bar chart. We start with our data list, which is simply a collection of numbers. These numbers could represent expenses or income in our app. To properly scale our chart, we first identify the highest value in the data set. For example, if the maximum value is 20, this serves as a reference point to ensure our chart displays all data proportionally. Next, we set a fixed maximum height for the chart, which in this case is 200 dp. Once the maximum value and chart height are defined, we calculate the height of each bar. The formula takes the data point, divides it by the maximum value, and then multiplies it by the maximum chart height. This ensures that each bar is scaled correctly while keeping proportions intact. Additionally, by applying a safeguard that prevents any value from being too small, we make sure that even minor data points are still visible on the chart. To efficiently manage our financial data, we use a monthly data class. This class bundles together key details such as the month's label, total income, and total expenses. To visually represent this data, we create a bar item composable, which acts as an individual bar in our chart. This composable takes in a monthly data object, a maximum value for scaling, and a selection state to highlight specific bars. The layout consists of a column structure within a box, and the label appears below it. Inside the box, we further divide the bar into two sections to differentiate between income and expenses, both proportionally scaled relative to the maximum value. To maintain a consistent design, we use our custom CW text component to display the month's label, ensuring clarity and readability. Now, let's talk about the overall structure of our bar chart. In our Cashwise app, the bar chart composable is responsible for creating a dynamic and scrollable visualization of monthly financial data. This component allows users to interact with the chart, highlight specific bars, and analyze trends. The chart includes a vertical axis for labeling values. The range of values extends from 0 to the maximum financial value in the dataset, and it is divided into 4 equal intervals. This structured approach ensures that the scale is well distributed, making it easier for users to interpret the data at a glance. Finally, we implement a horizontally scrollable row of bar item components, where each bar represents a specific month's financial data. This scrolling functionality allows the chart to accommodate large data sets, and just like that, we've raised the bar. A line chart is a powerful way to visualize trends over time by connecting data points with straight lines. It consists of an x-axis, which typically represents time, and a y-axis, which represents the measured value. By plotting the coordinates of each data point and connecting them, a line chart effectively illustrates patterns, relationships, and fluctuations in data. To mathematically construct a smooth and scalable line chart, we start with a list of data points. These values represent the measurements we want to display in our chart. The first step is to determine the maximum value in the dataset. For example, if the highest value is 90 on a Friday, this helps us properly scale the y-axis so that all points fit within the chart. Next, we calculate the x-axis step size to ensure that each data point is evenly distributed across the chart's width. This guarantees a well-proportioned layout, regardless of the number of data points. To fit all values within the available height, we introduce a scale factor by dividing the total chart height by the maximum value. This allows every point to be plotted within the designated space while maintaining accurate proportions. Once scaling is in place, we can convert raw data points into coordinates. The stas x coordinate is determined by multiplying the data index by the step size, while the y coordinate is calculated using the scaled value. Since screen coordinates on devices start from the top left corner, we subtract the scaled value from the total chart height to correctly position points from bottom to top. At this stage, we have everything needed to create a basic line chart. However, to enhance its visual appeal, we introduce midpoints between adjacent points. Instead of using sharp connections, we apply a quadratic Bezier curve to create smooth transitions between data points. This results in a fluid, natural-looking line chart rather than one with jagged edges. Now let's talk about how this is implemented in our line chart composable. This component is responsible for visually representing a list of expenses as a smooth flowing graph. The chart is drawn inside a canvas with a fixed size of 100 by 50 dp, ensuring it fits well within the app's layout. The first step in rendering the chart is normalizing the data. We identify the highest expense to scale all values proportionally within the available height. The step size on the x-axis determines the horizontal spacing between points, while the scale factor for the y-axis ensures that higher expenses appear correctly positioned at the top of the chart. Each expense value is then converted into its respective x, y coordinate, setting the foundation for drawing the line. To create a smooth curve, we begin at the first data point using a path function. From there, we loop through the remaining points and apply quadratic Bezier curves to ensure smooth transitions. Once all points are processed, the drawPath function renders the curve onto the canvas using the specified color and a stroke width of 3dp. Now we can literally see our money going up and down, hopefully more ups than downs. A pie chart is a circular graph divided into slices, where each slice represents a proportion of the whole. The size of each slice is determined by either its percentage or numerical value in relation to the total data set. This type of chart is especially useful for visualizing the distribution of categories within a data set, making it easy to see which categories contribute the most or least to the whole. To construct a pie chart, we start with a char list of numerical data points. The first step is to calculate the sum of all values in the data set, which in this case totals 255. This sum allows us to determine the proportion of each value. Using the formula that divides each value by the total sum and multiplies it by 360 degrees, We can convert each data point into its corresponding sweep angle, defining the size of each slice within the chart. To maintain a structured and intuitive layout, we set an initial start angle of 90 degrees, positioning the first slice at the 12 o'clock mark. To enhance readability, we introduce a gap angle of 12 degrees between each slice. This small separation prevents the segments from blending together, making it easier to distinguish between different categories. The drawing process follows a structured sequence. We start at the current angle, draw the slice using its adjusted sweep angle, subtracting the gap, and then update the start angle for the next slice. This approach ensures that each slice is correctly positioned and spaced within the circular graph. Now let's talk about how this is implemented in our code. We use a PyData data class to represent each slice in the pie chart. This class contains important details such as the category name, associated icon, color, and numerical value. The pie chart composable is responsible for creating an interactive and visually appealing circular chart that represents expense categories. Inside this composable, a canvas is placed within a box to draw each segment of the pie chart. To determine the correct size of each segment, we compute a sweep angles list, which converts each expense amount into its proportional representation out of 360 degrees. Then inside a loop, each segment is drawn using the drawArc function. To make the chart visually engaging, we apply a rounded stroke effect to the segments. Each slice is also assigned a unique color, parsed from its string representation, ensuring that different expense categories are easily distinguishable. At the center of the chart, we display the total expense amount, formatted as currency, along with a label. This provides users with an at-a-glance summary of their total spending while still allowing them to see the breakdown by category. A circular Venn diagram is a visual representation that uses overlapping circles to illustrate relationships between different sets of data. Unlike a traditional pie chart, which divides a circle into distinct slices, a Venn diagram focuses on intersections, showing how different categories relate to each other. To create our circular Venn diagram in the Cashwise app, we adapt the same arc drawing approach used in our pie chart, but introduce a key difference in positioning. Instead of drawing static slices, we arrange overlapping circles with varying radii. The process still involves calculating sweep angles and using the drawArc function to create arcs, but instead of keeping all segments within one confined space, each subsequent circle expands outward. To determine the size of each circle, we start with a base radius, which is defined as 1/4 of the screen width. For each additional circle, the radius gradually increases, ensuring a layered and proportional distribution. To structure the data efficiently, we introduce a new data class called CircleGraphData. This class contains 3 key parameters. For rendering arc-shaped indicators, we use a custom drawing function called drawIndicator. This function operates within drawScope and is designed to create partial circular segments. Instead of filling the entire circle, drawArc is used to render only the desired portion. The start angle controls where the arc begins, while the sweep angle determines how much of the circle is drawn. To keep the arcs perfectly centered, we calculate the top left offset based on the center coordinates. To enhance the visual appeal, we apply a stroke with a rounded cap. Several key variables play a role in positioning, sizing, and distributing the segments accurately. The X and Y coordinates of the center are calculated by halving the canvas width and height, ensuring that the diagram remains perfectly aligned. The radius of the indicator is set to 1/4 of the screen width. To ensure proper scaling, the largest data point in the dataset is identified as a reference. The dataset is also sorted in ascending order, allowing smaller values to be drawn first, ensuring that larger values do not overshadow smaller ones. Additionally, animation progress is incorporated, allowing smooth transitions when updating the chart. To finalize the design, we draw 2 indicators, one for the background circle and another for the foreground circle. This layering effect enhances depth and clarity, making it easier for users to interpret overlapping relationships within the dataset. With everything in place, we now create the Venn chart composable. To manage animations, we use Animatable, which enables smooth transitions when data updates. Each time the dataset changes, a coroutine is launched inside Launched Effect, resetting the animation to 0F and gradually progressing to 1F over 1,000 milliseconds using a tween animation. To ensure adaptability across different screen sizes, the screen width and height are dynamically calculated. The height is determined by dividing the width by a scaling factor, maintaining consistent proportions on different devices. Finally, we use a column layout to center the diagram and apply the draw behind modifier to render the pi indicator in the background, ensuring a structured and visually balanced appearance. With that, our circular Venn diagram is ready to go. Let's continue our journey as we dive deeper into building more dynamic and interactive components for our Cashwise app. To get started, we'll define two essential model data classes, progress bar data and income expense data. Now meet the progress bar composable, a sleek and intuitive way to visualize progress within the app. This composable takes in three key parameters. The first is progress, a float value ranging from 0f to 1f. Next, we have progress background, which sets the background color. Finally, we define progress foreground, which determines the color of the filled portion. The magic behind this component happens through the use of two nested box elements. The outer box acts as the full progress bar, stretching across the screen with a fixed height and smooth rounded corners to maintain a polished look. Inside this outer box, we have the inner box, which dynamically expands based on the progress value. With these foundations in place, we're well on our way to creating even more visually engaging components. Let's keep going. Next up, the spending item composable is like a mini financial tracker that helps you see how much you've spent in a particular category compared to your highest spending. It works by first calculating how much of the total spending this category represents. To make sure the value doesn't go too high or too low, it is kept within a safe range so that it always fits properly in the progress bar. To make the experience smooth, the progress bar is animated. Instead of jumping instantly to the new value, it gradually moves over 1 second, creating a nice transition effect that feels natural and polished. For the layout, everything is neatly arranged inside a column. The first row shows the category name on one side and the spending amount on the other, making it easy to read at a glance. Below that, the progress bar fills up based on how much has been spent in that category. Each category also gets its own color, making it visually clear and easy to distinguish. Here's a little preview of how it will look in the app. These two extension functions bring smart color logic to your UI, ensuring the right colors are applied automatically based on transaction types. The Get Text Color (TOH) function makes it easy to distinguish between debits and credits by assigning different colors, while Amount Color dynamically adjusts colors based on a Boolean value. This makes the interface more intuitive and visually clear. Moving on to Legend Item, this composable acts as a tiny color-coded label that pairs a colored box with a text description. This helps users quickly understand different chart categories without any confusion. The category chip composable takes this a step further by creating a stylish rounded chip with a color-coded label. It includes a soft border, smooth background, and proper spacing to keep everything looking modern and clean. To make it even better, it uses Legend Item to display a small colored indicator alongside the text, keeping things visually consistent. Next, we have CW Card, a sleek, reusable card component that wraps UI content in a well-styled, rounded background. With built-in padding and a polished look, it ensures that any content inside appears structured and professional. Just drop in your composables and CW Card will handle the aesthetics effortlessly. Now, let's bring all these card components together in our Cashwise app. One of the most exciting additions is the Finance Card, which beautifully displays total income or expenses over the last 12 months. It calculates the total, applies dynamic coloring using amount, and presents the final value in bold, easy-to-read text. To make financial insights even clearer, a smooth line chart sits beside it, visually representing trends and helping users quickly spot patterns in their spending or income. The Spending Bar Card composable provides a clear and organized breakdown of spending for a given month, making it easy to see where your money is going. It sorts the spending data, identifies the highest expense, and scales each spending item dynamically to ensure the progress bars accurately represent proportions. Everything is neatly wrapped inside a CW card, giving the chart a polished and structured look. Income expense cards composable takes adaptability to the next level. On smaller devices, it stacks income and expense cards vertically to fit the layout, while on larger screens, it arranges them side by side for better readability. The Circle Income Card Composable offers a clear visual breakdown of monthly earnings, making it easy to track income sources at a glance. On compact screens, it neatly stacks a Venn chart alongside a scrollable category list, while on larger screens, it lays them out side by side for better organization. The monthly bar card composable brings monthly financial trends to life by allowing users to visually compare income and expenses with ease. It features a dynamic bar chart where tapping on a bar instantly selects a month, updates the UI, and triggers an action with the selected month's label. To make things even clearer, color-coded legend items sit above the chart, making it effortless to distinguish between income and expenses at a glance. The balance card composable provides a quick snapshot of your current balance, combining essential financial details in a clean, structured layout. It prominently displays the formatted balance amount along with a details button that allows users to explore their finances further. To make goal tracking more intuitive, a progress bar below visually represents progress toward a financial milestone, helping users stay on top of their financial journey. Now that all our cards are complete, let's take a moment to preview everything and see how they come together in our app. The transaction category icon, composable, neatly displays a category icon inside a stylish, well-structured box. It dynamically scales its size using Get Scale Factor SAW, ensuring the icon adapts perfectly to different layouts. The icon sits inside a rounded container with a theme-based background color. Inside the box, the icon itself is displayed as text. The transaction item composable is responsible for presenting a transaction entry in a structured row layout. It starts with transaction category icon, followed by a column displaying the category name and subcategory using CDW text. On the right, the transaction amount is shown with a dynamically assigned color, making debits and credits easily distinguishable at a glance. The filter button composable creates a rounded, selectable button designed for filtering transaction types. It features a bordered and clipped row with a dynamic background color that changes based on whether it's selected or not. When tapped, it triggers On Filter Selected, Store or Style, updating the filter selection. Inside the button, the text is displayed using C to W text, ensuring consistency with the rest of the UI. To bring everything together, the filter row composable arranges a row of filter buttons, allowing users to select different transaction types effortlessly. It maintains a selected filter state, updating in real time whenever a button is clicked. As users toggle between filter buttons, the On Filter Selected callback is triggered, ensuring a seamless and responsive filtering experience. Now, let's bring the bottom navigation bar to life. First, we'll create a data class to store the icon, label, and index for each navigation item. The bottom nav bar composable sets up a navigation bar with 5 items, each represented by a bottom nav item data containing its index, label, and icon. The items list is remembered, preventing unnecessary recompositions and keeping performance smooth. The layout is handled with a row, ensuring all navigation items are evenly spaced for a clean and balanced appearance. To make things interesting, there's a special condition for the third item in the navigation bar. Instead of a regular button, it displays a floating action button with a plus icon, styled using the primary theme color. For all other navigation items, a regular navigation bar item is used. The icon color dynamically changes, with the selected item appearing in primary color and unselected items using on surface color. Now, onto the search bar composable. This component provides a clean and intuitive search experience. It maintains a search query state, updating in real time as the user types. The UI is wrapped in a box with rounded corners, keeping it visually sleek. Inside, a row aligns the search icon and input field, ensuring everything is properly positioned. The basic text field updates the query and triggers on value change, allowing the parent composable to react instantly to input changes. If the field is empty, a helpful placeholder, Enter Transaction Name, appears, guiding the user. The settings item composable creates a simple, clean, and clickable row for a settings option. It neatly displays a title using CW text and an arrow icon, making it clear that tapping the item will navigate to another screen. With arrangement.space between, the text and icons stay properly aligned, creating a balanced and visually appealing layout. When tapped, it triggers on-click, ensuring smooth and responsive navigation. Similarly, we'll create a notification item composable, but instead of an arrow icon, it features a toggle switch. This allows users to easily enable or disable a setting right from the row. Now, let's take a quick preview of all the amazing components we've built. Expanding our modules, setting up the dashboard. Building on our previous module, we're now setting up the dashboard data domain and presentation module. Here's a quick overview of the module and package names we'll be using. Before diving into the remaining screens, we need to do a bit of pre-work by adding some essential data classes and extension functions. To make financial data user-friendly, we introduce Format as Currency, an extension function that formats any number as currency with up to 2 decimal places. Another handy function, toDateFormat, converts a long timestamp into a properly formatted date string, using either a short or long format, depending on the user's needs. For filtering transactions, the filter type enum helps categorize them as income, expense, or none, making filtering straightforward and efficient. Additionally, the analytics data and dashboard data classes store key financial insights such as income, expenses, monthly trends, charts, and recent transactions, setting up the domain module and writing business logic. Before we dive into the business logic, let's set up our domain module properly. First, we need to include the common module and Android Core KTX dependencies in the domain module. In the data module, we'll be working with the dashboard domain and database module, which we created in the last video. Moving on to the presentation module, we'll add the required dependencies for Coin, Jetpack Compose, and the domain module. And yes, don't forget to add the Compose plugin to keep everything Compose ready. Now that our domain module is configured, it's time to write the core business logic for handling transactions and analytics. The dashboard repository interface defines a suspend function, getTransactions, which asynchronously retrieves a list of transactions. This serves as the data source for the use cases that follow. The getTransaction use case class fetches transactions from dashboard repository and applies filters based on filter type. Income returns only credit transactions. Expense returns only debit transactions. None returns all transactions without filtering. Next, the getAnalytics data use case processes transaction data to generate financial insights. When executed, it retrieves all transactions and separates them into credit transactions, income, and debit transactions, expenses. It then calculates total income and total expenses by summing the respective amounts. To structure financial trends, transactions are grouped by month using their formatted dates. For each period, it calculates total income and expenses, then maps this data into monthly data objects, providing a structured monthly financial summary. For income analysis, transactions are grouped by month and category name to generate circular income chart data. Each category's total amount is calculated and a circle graph data object is created. For expense tracking, transactions are grouped by month and category name to generate bar chart data. The total expense amount for each category is calculated, assigned a category name and color, and stored as progress bar data. The data is then sorted in descending order, ensuring that the highest spending categories appear first in the bar chart. Finally, all these insights are combined into an analytics data object, which is then returned, providing a comprehensive financial overview for the user. The Get Dashboard data use case is responsible for fetching transactions from dashboard repository and calculating key financial insights. It determines the total income, total expenses, and current balance, giving users a quick overview of their finances. Additionally, it extracts the 5 most recent transactions, ensuring that the dashboard always displays the latest financial activity at a glance. For pie chart data, the use case filters out expense transactions, debit, and groups them by category. It then calculates the total amount spent per category and extracts important details like the category name, color, and icon. These are mapped into pie data objects, making it easy to visualize spending patterns. Finally, all this information is packaged into a dashboard data object and returned. Moving to the data module, the dashboard repository impl handles fetching all transactions from the FinanceDAO database. It then maps them into transaction objects while correctly identifying their type as credit or debit. To ensure that the most relevant data is always at the top, transactions are sorted by date in descending order. To tie everything together, the dashboard data module is created as a coin dependency injection module. It includes the Room module for database setup and provides a singleton instance of dashboard repository impl, binding it to the dashboard repository interface. Now, let's move on to the presentation module, where we define the MVI contract for the home screen. We start with the Home UI State data class, which holds everything needed for the home screen. To handle events, we define the Home Event Sealed interface, where load data serves as the trigger for fetching and updating dashboard data. The Home View model is responsible for managing the UI state of the home screen. It uses mutable state flow to store the current home UI state and exposes a read-only state flow, ensuring that the UI can observe changes without modifying the data directly. When process event home event.load data is triggered, the magic happens. The function calls load data sign, which launches a coroutine in view model scope, fetches the dashboard data from get dashboard data use case, and updates the state accordingly. This ensures that the dashboard is properly populated, the loading indicator stops, and a quick check determines whether transactions are available. Building the home composable. Inside the home composable, we start collecting the UI state and use launched effect to trigger process event home event.load data, ensuring data is loaded as soon as the screen appears. We then define a scrollable column to structure the layout. At the top, we display a welcome header, followed by the balance card we created earlier in this video. Next, we check if pie data is available from the use case. If it exists, we display the expense pie chart, making it easy to visualize spending patterns. Similarly, we check if recent transactions are available. If they are, we display them inside transaction item components for quick access. If no data is available, we show a friendly message, no transactions available. To encourage users to get started, we also add a button that allows them to add their first transaction effortlessly. Here's how it looks. When data is available, notice how categories appear on the left in expanded screen sizes, ensuring a clean and structured layout. When there's no data, the UI gracefully adapts, displaying an empty state message along with an action button. Now, let's move on to creating the transactions. Defining the MVI contract first. We quickly define the MVI contract for the transaction screen. We have 4 event types. 3 for filtering transactions, 1 for loading all transactions when the screen is launched. Next, we set up the transaction view model, which takes get transaction use case as a parameter. Whenever process event is called, it invokes load transactions with the appropriate filter type, ensuring the UI updates with the correct set of transactions. The transaction screen composable observes the transaction state from transaction view model using collect as state with lifecycle. When the screen is first launched, it triggers transaction event.load transactions to fetch and display transaction data. Inside the column layout, we arrange the main UI components. A header with a download button for exporting transaction data, a search bar to allow quick searching of specific transactions, a filter row, enabling users to switch between all transactions, only expenses, or only income. When a filter is selected, it calls transaction view model to reload the data with the chosen filter, updating the UI instantly. Once data is loaded, transactions are displayed inside a lazy column. Transactions are grouped by date, with each section starting with a sticky header that shows the formatted date, making it easy to distinguish transactions from different days. Inside the lazy column, we iterate through the list of transactions, displaying each one using transaction item, ensuring a structured and user-friendly view. Here's a quick preview. With this setup, the transaction screen is clean, intuitive, and easy to navigate. Users can filter, search, and view transactions effortlessly. To start, we define setting type, which allows us to display 3 different types of views: title headers, settings items, and switch items. The settings view model is straightforward. It simply sends a list of setting type items as part of the initial UI state. No complex logic here, just a clean way to manage and display settings. Inside the settings screen composable, we use a lazy column to list all settings options. The UI dynamically renders headers, clickable items, and switches based on setting type. It observes the settings state from settings view model, ensuring any updates are instantly reflected in the UI. This makes it easy to navigate and customize user preferences. Moving to the final screen. Analytics. For the analytics screen, we first define the MVI contract to structure our state and events properly. Since we've already built multiple screens following the same approach, the analytics view model will feel very familiar. So instead of lingering on repetitive setup, we'll move quickly to the fun part, building the actual screen. The analytics screen stacks all the financial cards we created earlier inside a scrollable column. This ensures that users can effortlessly navigate through key financial insights, including income trends, expense breakdowns, and spending patterns all in one place. We have everything in place, but before we hit that run button, we need to do some final integrations to make sure our app works smoothly. First, we'll create the coin module to manage dependencies, but by now, I'm sure the code is pretty self-explanatory, so we won't dwell on it too much. Next, we need to add the dashboard module dependency in the main presentation module and ensure that the dashboard module is properly included in it. For navigation, we'll define the destinations for all four screens and ensure they are serializable, allowing us to pass data between screens easily. As part of the final cleanup, we'll refactor the existing implementation of CUApp. This involves removing the highlighted code and instead moving the add record screen and transaction category composable into the appropriate module. With this change, Navigate to Dashboard will now have only one composable to load, authenticated home screen. Inside Authenticated Home Screen, we'll use a scaffold layout to manage the bottom navigation bar. Based on the selected index, it will dynamically load the appropriate screen, ensuring smooth navigation across the app. It's time to run the app. And that's a wrap. This was the final part of our series, and we can't thank you enough for all the love and support along the way. We hope you learned a lot and had as much fun as we did. If you enjoyed this journey, make sure to like, subscribe, and share it with your friends. More awesome content is on the way, so stay tuned. To get the complete code and support us, check out the link in the description. Until next time, happy coding.